When you haven't seen people in a very long time, you just don't realize how much they've changed.
Well, I just love old people, yes I do. I just love old people. How about you? With silver traces in their hair, there's so much wisdom they can share. I know of none that can compare with old people. So when you're old and turning gray, I hope that you hear someone say, I just love old people.
Hey, I got my hair coloring back in. I got the gray all taken away. And so, looking good. No, this is my real hair. That was fake. This is real, just like you with your gray mustache. Maybe that was real. You know, math teachers don't grow old. They say math teachers don't grow old, they just tend to infinity. Others say math teachers don't grow old, they just become irrational. Or math teachers don't grow old, they just lose some of their functions. Or math teachers don't grow old, they just start using strange expressions. But however it is, this is Friday, and we only have 2 e-learning days left. And so we still got a lot to learn. And so get the attendance taken. It's Friday, May 22nd. It's my mom's birthday. And this is your e-learning for pre-algebra today. And so just remember that everything we're doing is going to be on worksheets. And so you can get your textbook turned in. You can take your cover off your textbook. Just make sure you have it and bring it to school when you come and pick up stuff out of your locker. If you already have everything out of your locker, you still have to come to school to drop off your textbook. So I can have that and collect that, okay? And so we'll try to be there as part of the collection. But everybody will have to stay in the car, but we can wave and things like that. So yesterday or Wednesday, we talked about permutations. Today we're going to talk about combinations. Tuesday we're going to talk about permutations with repeated things that have the same, like we're going to talk about repeated letters in an ordered arrangement. And then Thursday, on the last day, we're going to do Venn diagrams. And there will be homework even on the last day that you have to just get done right away and get all that stuff in. Okay? And your logic problems are due. And so turn them in today, turn them in tomorrow. Just try to get those done. Okay? So when we talk about combinations, we want to talk about how they're different from permutations. Permutations, so this is assignment number 129, notes 129. A combination is an arrangement of objects where the order does not matter. They are unordered. And so there are less of these than there are permutations. In a permutation, if I said Alex Blakely, it's a different order, Blakely Alex. And so that would be 2 orders for 2 people. But if I just said I wanted 2 students, it didn't matter who I called first. That would be a combination, and we're going to compare those right now, just talking about the letters in cat. And so to do any more than that, just doing a 4-letter word math last time about wore us out. So we're just going to do cat this time. And so the question says, how many ordered arrangements of cat? Well, you could write C-A-T, C-T-A, TAC, TCA, and what are some other ones we could have? What would it be? Joseph? Yeah, the ones that begin with A. We could act on it. ACT and ATC. And so we would call this 3 pick 3. Which from our work on Wednesday is 3 factorial, which is 6. What about 2-lettered arrangements of the word cat? What would that be? Seth? You mean I could just take the first 2 of all these and move it over here, and that would be the 2-letter arrangements. It's very good, Seth. We could do CA, CT, TA, TC, AC, AT. That would be 3 pick 2, which would have been 3 factorial over 1 factorial, which still is 3 factorial. And see, that would still be 6. What about 1-letter arrangements of cat? Well, I could pick a C, I could pick an A, I could pick a T. That would be 3 pick 1, which is simply 3, because it'd be 3 factorial over 2 factorial. Now, how many ways can you pick none? Would it be 0? No, Josiah, you're right. It'd be 1. Well, I can't even write it. How do you say there's 1 way to pick 0? There's nothing to write. But the answer is 1 because there's 1 way to do it. It's to not pick. There's 1 way. And so 3 pick 0 is 3 factorial over 3 factorial, which is 1. It'd be just like if your mom said, hey, you want to have a birthday party? You can pick friends. I picked nobody. See, that was 1 way. You picked nobody. And so you picked 1 way to pick nothing. Now let's talk about how many unordered arrangements can you have of cat. Where if I'm picking the 3 letters, I just want to pick 3. The order doesn't matter. I could pick a C, I could pick an A, and I could pick a T. Notice I put commas between them because they're not ordered. And all of these are just a C, an A, and a T, and there's only 1 way. So that means that 3 choose 3, see we're going to change it to choose, equals 1. Interesting. How many ways could you choose 2 where the order doesn't matter? Well, I could pick C with an A, but that also includes A with C. I could pick C with T, but that would also include T with C. And I could pick A with T. And there are 3 ways. How many ways can you pick 1 letter? Well, I could pick a C, I could pick an A, or I could pick a T. Well, that's 3 ways. How many ways can you not pick? That would be, so this is 3 choose 2. This is 3 choose 1. And this would be 3 choose 0. Now you have a button on your calculator, you could just type that in. But guess what? 3 choose 0 is 1, just like 3 pick 0 is 1. How many ways to choose none? 1 way. I didn't choose. I chose not to choose. And so there's a lot of interesting things going on. One thing is, when we started throughout the year, if we ever talked about Pascal's triangle, there's something called 1, 1, 1, 1, 2, 2, 1, 2, 1, 1, 3, 3, 1. And you will notice that our answers right here, 1, 3, 3, 1, just happen to be this row in Pascal's triangle, 1, 3, 3, 1. But the thing is, I want to relate each of these answers to what we did on Wednesday. How do you go from 3 pick 3 to 3 choose 3? How would you go from 6 to 1? How would you go from 3 pick 2 to 3 choose 2? How would you go from a 6 to a 3? By doing the same thing. How would you go from 3 pick 1 to 3 choose 1 by doing the same thing? I'm so confused. How would you go from 3 pick 0 to 3 choose 0 by doing the same thing? What's that, Ian? You would divide by how many you're choosing factorial. So 3 choose 3 is 3 pick 3 divided by 3 factorial. Whoa. 3 choose 2 is 3 pick 2, which is 6, divided by 2 factorial. That does work. 3 choose 1 is 3 pick 1, divided by 1 factorial. That would work there. 3 choose 0 is 3 pick 0, divided by 0 factorial. And remember, Gloria, 0 factorial equals 1, even though it's like, why doesn't it equal 0? But it equals 1, and so that's how you'd still get the answer of 1. And so we have a new formula for today. And the new formula is this. It is n pick r, which was Wednesday's, divided by r factorial. That's what Ian just said. But remember, yesterday, Jack, n pick r was n factorial over, yes, it was n minus r factorial. And so that was the permutation formula. But now I also have to divide by r factorial. So the combination formula is n factorial over the quantity n minus r factorial times r factorial. You got 2 numbers on the bottom you're dividing by. So if I have 5 choose 3, what we want you to do is try to write it like this. 5 choose 3 is going to be 5 factorial over what 2 factorials? What's 5 minus 3? 2 factorial. What's the r? What you're choosing? 3 factorial. And so you will write that. Now an easy thing is, what do the 2 numbers on the bottom always have to add up to? What do r and n minus r always add up to? They add up to n. So your 2 numbers on the bottom will always add up to the top number. And so if you want to do this by hand, 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 would just leave 5 times 4, and then you divide that by 2 and you get 10. 5 choose 3 is 10. 6 choose 2, you do 6 factorial. Then you do 6 minus 2 is 4. And then you also take this number, but 4 plus 2 is 6, so you already knew that those are the 2 numbers on the bottom. Well, 6, 5, 4, 3, 2, 1 over 4, 3, 2, 1 is 6 times 5, which is 30. But then you also have to divide by 2 times 1, which is just 2. And so 6 choose 2 is 15. There are 15 ways to choose 2 people from 6 people. What about 7 choose 4? What would your 2 numbers on the bottom be, Layla? Yeah, 3 and 4 or 4 and 3. Multiplication's commutative. It doesn't matter which one you write first. 7, 6, 5, 4, 3, 2, 1 over 4, 3, 2, 1 is 7, 6, 5. But then that's over 3, 2, 1. And 3, 2, 1, 3 factorial is a 6. So then 7 choose 4 is 35. Now, that's the combination formula. Now, what is the difference between a permutation and a combination? Permutation means the order matters. If we had tests and quizzes, boy, you lucked out. You would have to determine which one's which. We would have a test over this, and you would love every second of it. If you're going to put 9 books in a row, how many ways can I put them in a row? That would be a permutation, and we would do it like we did on Wednesday. If we are just selecting 3 books out of 20, you go to Mrs. Schmidt in the library, and it's like, you choose 3 books. Does it really matter which one you picked first? No. And so that would be a combination. So this would be 9, pick 9. I'll write it this way because it's easier than me writing combination or permutation. This one, write an arrangement of the letters in the word book. Well, this would be a permutation. But I can't write it as 4 pick 4. Well, I could. But 2 of the letters are the same, so we're going to have to divide this by something. Come back next week on Tuesday. We're going to talk about how we do that. how many ways to arrange the letters in book if two of the items are the same? And so there's always more to learn. And then we have to discuss it. And so even though the school year's ending, there is no ending to the learning. So let's talk about these. How many ways can a committee of 6 be chosen from 5 teachers and 4 students if all are equally eligible? So how many total people do I have, John? I have 9. This would be 9 choose 6. If I wanted to write it out, it'd be 9 factorial. And what 2 numbers would be on the bottom? Lucas? Yeah, 6 and 3. Now we could just type this into the trusty rusty calculator. And so we could do 9 times 8 times 7. And then 6, 5, 4, 3, 2, 1 cancel. And then divide by 6. Which gives you 84. Or you can just hit the button that says 9 choose 6. Just go to the PRB button. See, it says 9 choose 6 and says 84. And that also works. What about we can make them harder. A committee must have 3 teachers and 3 students. So if I want a committee of 6, 5 teachers, how many am I choosing? 3. I have 4 students. How many am I choosing? 3. What do you think, Alex, we're going to do with these 2 answers? Are we going to add them or multiply them? Yes, we're going to multiply them, just like that little Bobby Bear dressed in shirts and overalls. Each of these, it'd be the same problem. And so to choose 3, if you had 4 people, to choose 3 of them is the same as not choosing one of them. And it's the same on Pascal's triangle. That's why Pascal's triangle is a palindrome. It's the same forwards as backwards. This next one. How many 5-card hands can be dealt with 52 cards in a deck? Well, that's just 52 choose 5. The order you get the cards doesn't matter. And so this would be 52 factorial over 47 factorial times 5 factorial. Now, if you don't have a button on your calculator that does this, you need to put parentheses around the bottom. So you're dividing by the whole thing. Otherwise, there's a button. Just use the button. And it's a big number. How many how many hands of cards, or whatever you say it, can you be dealt? 2,598,960. It'll be good to be back in a room just talking to you guys regular, not through video stuff. But we've tried to make the best of it. And I know you have too, so great job. How if the 5 cards must be from the same suit? Well, how many suits are there? Well, there's 4. How many times does 4 go into 52, Caden? 13. So this problem is really, you have 13 choose 5. So you could do 13 choose 5. But since there can be in any of the, I could have 13 choose 5 of the hearts, or I could have 13 choose 5 of the clubs, or I could have 13 choose 5 of the diamonds, or I could have 13 choose 5 of the spades. But most of the time, how many groups of 13 choose 5 do you have? You have 4 of them. You have 4 times 13 choose 5. You can actually type all that in. You can actually do 4 times 13 choose 5. Or you can just do 13 choose 5, which is 1287, times 4, which should be 5,148. So you know your brother or sister are cheating at cards if they always have a good hand. They got the cards marked. And these last 2 are actually on the homework. And so I put them on here, and so then I don't have to give you hints on the homework. They're the same problems. In omelet, you can choose 2 of 6 vegetarian ingredients or 1 of 4 meat. What are total possible omelets? Well, you can do 6 choose 2. And you can do 4 choose 1. And if they're happening at the same time, you multiply. Now that means you have to choose 2 of the 6. And you have to choose 1 of the 4. This next problem, though, You can order an omelet with nothing, or 1, or 2, or 3 ingredients. Well, how many ingredients are there? There's 10. So I can order an omelet as 10 things, and I can choose none of them. Well, that's one way. I could have an omelet, 10 of them. I could choose one of them. Well, 10 choose 1 is just 10. Then I have an omelet. I have 10 items. I could choose 2 of them. And what would that be? And then I have an omelet, and it's 10 choose 3. And then I add all these together. And why didn't I finish these even though this is the notes? It's because they're on the homework right down here. The same problem. Oops. And so when you get down to these, I'm just going to do a couple of them so you know exactly how to fill this in. So like on the story problem, it says, how many ways can a 4-person committee be chosen from 9? The first blank is 9 choose 4. The second blank is your formula. 9 factorial, and then what 2 numbers go on the bottom? Xavier? Yeah, 5 factorial and 4 factorial. And then you type in your answer. You can type this into your calculator. You can type the factorials in your calculator. You can think about it a lot of ways. But if you're going to type this in, and you're going to type it in, make sure you... There's 7 of them. You're choosing 6 at a time. I didn't give you triple blanks on this. I should have. And so it'd be 7, 6, 1, which is 7. I don't know why I didn't do that on this. 7 choose 4. You would do 7, 3, 4 on the bottom. You do 6, 7 choose 2. You do 7, 5, 2, but then actually answer it. I didn't give you enough space. Sorry about that. And the same thing up here on these. 8 choose 6 is 8 factorial over 6 factorial times 2 factorial. So 8, 7, 6, 5, 4, 3, 2, 1 over 6, 5, 4, 3, 2, 1 gives you 8 times 7. And then you divide that by 2, and 56 divided by 2 is 28 right there. Okay? And so you finish up the assignment. This is assignment number 129. And so hopefully you're not mad at me because we made you look funny on the notes. And if no one can recognize you anyways, they don't know who you are. And so, but make sure you get all your stuff in. You're going to get worksheets to the end. And so get all that ready to be brought back to school. Okay? We miss all of you, and we can't wait to be back in person teaching in the fall with you. And that's the best thing. So we'll still be together. Okay? Bye-bye. Have a great Memorial Day weekend. We'll see you later.